right. Good morning, everybody. We're right at 10 o'clock, so we're going to get started. We're going to have Jeremy up here talking about Town of Matthews tree assessment tool. So.
All right, good morning, everybody. It's good to see you all here. As he mentioned, this is the Town of Matthews Tree Canopy Assessment Tool. I am a recent graduate of the Master's in Geospatial Science program at NC State, and in the last semester there, they partner you with different groups around the state to try and accomplish a task that they want done that has some sort of geospatial solution. So that's how I got partnered with the Town of Matthews, their Appearance and Tree Committee or Town Beautification Committee, whatever they decide to go by when you talk to them. So a little bit of background, Matthews, North Carolina has a Tree City USA designation, and there are several bits of criteria to get this designation, but one of them is you have to have an appearance and tree committee, and that committee came to us and said, we would like you to develop us a tool that will allow us to assess the health of our tree canopy year after year. So that was their main goal that they wanted us to try and accomplish. And as I go through this, I may rush through a few things. At the end, if you need me to elaborate anything or grab me afterwards, feel free to do so. So the problem they had, for one, is their assessments currently are only in the years 2001, 2008, and 2016. Originally, when I got into this, I thought that was a little spaced out, but some of my research came to tell me that that's actually the pretty normal spacing to notice large changes over time. But they were interested in having them a little closer together, or they wanted the ability to update them if they had a specific year that they wanted to look at. Additionally, their data sets they had were too large. So the assessments that they currently had in their possession were for the entire county of Mecklenburg. And as you can see in the bottom right corner, the town of Matthews is just a little bit of that. So as you all know, working with raster data, that's a lot of information that they don't need, that crashes computers and make things run slow. Additionally, this is a group of volunteers who don't do GIS full-time, who don't have GIS-capable machines, or the software to view this data. So if you ask for something as a non-GIS individual and someone handed you a raster file, what are you going to do with it? How are you going to open a 50 gigabyte GeoTIFF, right? And additionally, it's not quantifiable. So they have this image that's a pretty picture. Obviously, green probably represents trees and purple's probably something else. But as again, a raw raster file, they can't do anything with this information. So they really wanted to be able to work with this, make decisions with it, and share it with the people of their community. So to approach this problem, first we wanted to develop a classification process. Obviously, you have supervised classification within the Esri software, but that involves a lot of manipulation, a lot of checks and balances here and there. So what we wanted to do is take that process and reduce the user input and streamline it as much as we could. Additionally, as mentioned, that produces a raster file. So we wanted to get this in a way that that data is usable, quantifiable for them to make decisions based on. Moving on from there, just a little tag on to maybe improve the capabilities of the tool we give them. We wanted to involve and educate the community with about the trees, whether individual trees or the overall status or the overall trend of the canopy in their town. And we wanted this to exist in a web-based application because, as mentioned, not everyone's going to have the hardware that has the ability to run these programs. And we wanted everyone to be able to access it, whether from a phone, computer, tablet, whatever they have to at their disposal. So on the right, you can see, on your right, you can see kind of the overall what the app looks like in its finished form. And it includes the tree canopy assessments from the year 2016 to 2022. The reason we started at 2016 was, one, we had a comparison to go off of because they provided a 2016, so we could say this is what they acquired, how does what I gave them, what we produced together, how does that compare in quality, so to speak. And additionally, the image data set I pulled from, which is planet data, for this area, they only went back to 2016 as far as what was provided for us. It exists in a couple different manifestations. So there is a desktop tool because you don't want to be running image classification through a web-based application. And if you're updating a ever-existing database, you don't want everyone and their brother creating unnecessary canopy assessments that exist side by side and make everything so it doesn't even work. So that is a kind of a back-end user interface that they can use to update the web application. And here we have the web application. These exist as links, but when I left the program and had to hand everything over, there were some data ownership issues that I have to go back and get worked out for it to exist again. So unfortunately, I couldn't have the QR codes for you guys to check it out, and I apologize for that. So in addition to that web application, we have a survey that I'll go into in a minute, because part of this committee, they have a legacy tree database. Again, I'll talk about a little more in that in the future. And the survey is the way to update and geo-reference those data points, essentially. So for our streamlined assessments, as you can see through this model builder, you can, there are several steps built into this essentially 3-input process. The steps include, for one, it produces the new tree assessment. It takes that assessment and vectorizes it and gives you an area coverage calculation, and additionally a % canopy coverage calculation from that. And once each individual assessment is complete, it adds those to a single database file for projecting those bar graphs that you saw a minute ago, and I'll show again on the next slide. Additionally, as I said, it's minimal user input. So all these steps shown here and everything, if you've done supervised classification, everything's preset so that all the individual has to add is the individual raster files. And then they have to update the training samples. So my goal here was to make it automatic. But I figured out date to date, year to year, you cannot effectively automate this process because the training samples pull from that raster file and they're different based on colors. So what we did instead here is I created a training sample set of about 100 training samples in the area, and those exist and automate and create a new training sample file every time the tool is run. So that way those samples apply to that raster image, and you're not pulling data values from a previous assessment. But additionally, I have a stipulation for whoever's running this that you need to look at it and make sure that from 2022 to 2023, they didn't clear cut a forest, so you don't have several acres of building registered as trees. So that's in there, but aside from that, this is about as automatic as I could figure out how to get the process. So in addition to those individual images, and that all you need to do is put the date of the training sample, and that is just to keep things in order. So the features of the application, as I mentioned, the bar graph representing 2016 to the present year. This is for the overall canopy status tracking. It depicts the change. Year to year, there's not a lot. And this is when I figured out, okay, that's why they do 7-year increments, to not waste money and learn nothing. And as you hover over them in the application, you can see the square miles and the % coverage from year to year. And additionally, as a way to explore that, I added a tree canopy comparison via the swipe tool within the application. So you can see in this image on the left, this is the same section. This section of trees in 2016, as I mentioned in my example with the training samples, it is trees, and then in 2022, it is clear cut. So by taking your 2 layers and running that swipe tool, you can see the major changes in the landscape. And like I said, I wish I could have pulled it up on the application and shown you each individual years, but that is not currently working. And the idea here is to highlight those large development projects, as I mentioned, and I'll get into why in a moment. A secondary, and this is why, a secondary feature of the tool is the idea of development planning. So you have your canopy as it exists currently, but say you have a group that wants to come in and clear cut a section to develop something. Well, part of the goals of the beautification committee are to regulate how much is cleared and keep an idea of how each project impacts overall the status of the tree canopy. So using this tool, you can go in and say, okay, we're going to clear this section of trees, okay? And then once you do everything, I'm going to go walk through it step by step, but once you run the complete tool, it'll calculate and give you those area percentages and recalculate the canopy, saying if we had 50% canopy coverage and you run this project, here's what it goes down to, 49, 48%, whatever. In addition, in order to offset those, I added a feature where you can say, okay, here's an area that doesn't currently have anything in it. What does it look like if we plant trees here? So aside from the clearing portion, you can go in and highlight areas where you'd like to plant trees. Obviously, this is predicting several years down the road. It's not going to make that impact the next time you do a canopy assessment. But it gives you an idea of how you can offset these developments, how you can maintain your tree canopy without halting advancement of society, so to speak. So once you have your cleared files and your plant files, you can see on the bottom left, that is the current canopy before the tool is run, and on the right, it redoes that canopy with your clearings, with your additions, and at the very bottom left, you can see how it shows you those calculations. So now we go into the survey that I mentioned a minute ago, which is another feature of the app. This leads into that feature. The idea of this database is to help visualize these data points. So the legacy tree is an initiative within the town of Matthews. It might be commonplace, I'm not sure. But specifically with them, they go around, people on private property, public property, can petition to have these trees registered as what they call legacy trees. And this could be a specific variety of tree that might be kind of unique to the area. For example, there was a dawn redwood that I'd never seen. I'm not a tree person. I like trees, but I'm not a forester, we'll say it that way. They had a dawn redwood that was very nice, and there was only one really that I saw within the town. So that place had that property that it was on had it petitioned to be a legacy tree. So it goes into their database of what's the location, what's the height, what's the estimated age, what's the width, why is this special? And the idea here is to encourage the protection, the preservation of these large, unique trees within the town. But at the moment, it exists in a spreadsheet somewhere. And when you're talking about trees, wonderful, beautiful things that we can look at, see from all around that improve the image of the town, the curb appeal of the area around it, that information is not beneficial in a spreadsheet somewhere. So this survey came to fruition as a way to get those with coordinates associated with them and an image and a way people can look at them. And this is just how the survey exists. It goes through what's your name. If you want to remain anonymous, that's fine. The date of submission. It uses the GPS coordinates of your phone and accesses your phone's camera so you can take a picture and upload it to that. And the nice thing about this is in addition to your official legacy tree, so to speak, you can have community submitted entries, and that goes into your community involvement and education. If you want to be especially nerdy about it and say this is a Facebook for trees, go for it. That's all the better. And it's a way, if you go into the information, you won't be able to say this is a legacy tree for everything. But maybe it's an individual that had a tree they walked by when they used to walk to school every day, and it's important to them. So they can add that and say, why is this important to me, and share it with those around them, whether it's your fellow tree lovers, whether it's your development planners and you're trying to save your tree, whatever it is, whatever you can get out of it that's a benefit, go for it. And this is how that survey exists within the app. You can see in the bottom right 3 images how those georeference points show up in the application. It shows the locations. On the very top, you can see 2 of the preset filters that are kind of built in. One is just search the tree species or search by the tree species. So on the left of the 3 tree images, that's confusing, where it says all trees, there we go, I made it easy for you. You can see all the trees that have been uploaded in this section. But if you select just the southern magnolias in the middle, you can see that just those 2 show up. So outside of that filter, there's the option of, do you want to just look at your legacy trees, or do you want to see what your friends and neighbors and other community members have added? So that's why you have the option to filter by the legacy trees. So on the right, you can see the legacy trees. But now what does it look like if you click on one of these points? The bottom left 2 images show you the data block that pops up when you select one. It shows you who submitted it, when they submitted it, what the species is. And this, when you in the survey, the default to this is, I don't know, please tell me. And this allows members of the tree committee to go in, look at your images, and hopefully take an educated guess on the tree species based on that. This really allows you to interact with the data and visualize the legacy trees and visualize the trees in a way that words can't. So what did we really get out of this? It's a maybe you like it, maybe you don't. It's a nice interface for anyone in the community to view the tree canopies, to make decisions based on that and do some plantings. Maybe you just want to cut a tree down in your yard and you're curious as to the impact of that would have on the overall status of the tree canopy. But the reality is now I'm not a registered GIS professional, so I don't want to insult whoever did the original tree canopy assessments, but in the top two images, you see the satellite image that was originally used and the assessment result that was originally provided, where it had all these soccer fields registered as tree canopies. And even the bottom left soccer field, you can see a strip next to it, which is just a strip of shadows. It had that classified as trees. If I had to guess, I would say they picked a data set, a training sample set that was not specifically relevant to the Matthews area, and that's why it was not specifically accurate. But their assessment for the year 2016 said that this town had 70% tree canopy coverage. I've been to the town, it's got a lot of trees, but it's not 70% covered. Mine, I will admit, it's an underestimate. This is because my imagery was 3-meter resolution, so if you had a tree small that's not that wide, it's not gonna count it. Your narrow strips of trees, as you can see in the bottom two images, it's not gonna count it. But my estimate was closer to 50%, 45 to 50% over those years. And while that's still inaccurate, and I'll admit that, I think for the use of preserving and growing your tree canopy, it is much more beneficial to underestimate and be conservative, not clear an area because it's gonna remove 10%. If you think you've got 40% canopy coverage versus 70% canopy coverage, because you're going to be much more protective of what you see. And as mentioned, the limitations of this are really when you have a single tree in someone's yard or if you have narrow strips along the roadside. Future development for this, this is a little outside of the scope of what this tool is supposed to cover, but the mayor asked if this was possible, so I included it. Further classification, more sets of, is it a building, is it road, is it sidewalk? That's possible. It's not going to happen within this application, but if they wanted me to do something outside of that for them, I could. I'd like to get this with high resolution imagery to be able to at least classify whether it's deciduous or coniferous, just another point of interest. And then I'd like to be able to get it to custom reporting. So when you run those planting and clearing estimations, you'll be able to save them and compare them side by side and say, okay, well, what if we go this route? What if we go this route? What's the best outcome for the town? And I'm still working with them. I work for NC State, so I have access to a lot of very nice software. So as long as I don't let them pay me for anything, I'm gonna keep working with them. So in conclusion, these are some of the overall goals I've got laid out here of the committee and how this tool helped to address them and maybe give them a little bit of a way as volunteers, as maybe those less versed in the GIS world and the software world to really utilize this resource and see how they can interact with their community, improve the tree canopy, and preserve it. And just as some acknowledgments, I worked with Devin Rankin, who she was my point of contact on the committee, and the Town of Matthews Board of Commissioners, and then my class and my instructors for helping me troubleshoot and test things out.
Anybody have questions?
Okay, we'll start with you.
Sounds good. So first of all, that's awesome. Very cool app. I'm sure I've worked for the city of Greensboro, and they are looking for something very similar. So you gave them an opportunity to see their data in a very cool way and to take all the complicated stuff and hide it behind that nice hat. Very good. One thing that we're starting to look at is the new 2022 ortho photos. They have a color infrared band, which is very helpful for delineating tree canopies and boundaries of that sort. So, and you can go back with the ortho photos, it's like 6-inch resolution back to 2016 and possibly 2012. So if you wanted to incorporate more high-resolution data, you can incorporate those bands into existing data you have for the satellite imagery and get really fine-grained. If the mayor asks you to look at that, you can. But it's very good data, it's free. You don't have to worry about getting a grant or anything like that. It's all NC1 now. So.
Speaking of that point, I actually tried that to start with, the near infrared. So I work for agriculture and we do a lot of multispectral stuff. So that was my original plan to help for that delineation between even on a spatial level. But what I found was the NIR band saturates when you've got a full field of grass. So that was going to skew the purpose of this. So that's why I left that out. But I did try that.
Yeah, and just real quick, what I did for my master's thesis was very similar, but I incorporated LiDAR, created digital surface models and canopy models, and I created a mask so that anywhere that was below 1 meter, I masked it out so that I knew that was a field.
Right.
I had another data. There was some analysis in there, but it's
That's good.
LiDAR.
I like that. Yeah.
So, on this conversation about resolution, I thought I heard you say the resolution of your data was 3 meter. And I'm curious, for the town size, the geographic area of Matthews, is 3 meter appropriate? Would 1 meter be better? Or I'm curious if you think half or sub-meter would be too high resolution if you're QCing it.
So I'll speak to that and then I'll get to you because I saw yours after that. So the reason I went with 3 meter is because this was a partnership and they didn't have any funding to put towards it. And that Planet data, that was the highest resolution free data set I could go with for this developed as a proof of concept. But we actually I would like to have a much higher resolution. And there's another group within the town that is looking at purchasing a sub-meter resolution data set, either annually or every other year. And if they go into that, then I would redo this, incorporating that image set.
Could you compare your tree canopy data set to the statewide name-derived 1 meter canopy?
Not the statewide, I just used the one that they provided me because that was what they were comparing it to.
Just an FYI, there's a statewide 1 meter derived from named tree canopy.
Okay.
I'd be really curious just how you compare the resolution.
Yeah, I'll have to check that out.
Well, first of all, congratulations. This is obviously a ton of work that you put into this. And I really like the idea of the community trees because I'm a tree person and I do have like a favorite tree that I would really put in there. And I was wondering if you had thought about incorporating any open data sets into that, like iNaturalist, you can download their point data for specific trees and they'll be reviewed by some experts that are, you can filter for like research grade trees. And that might be an interesting thing to add into there if you're looking to expand that at all.
Okay, I'll look into that because that would be a good way to populate an initial data set. Yeah. Yeah.
Coming back to the LiDAR data, there is a 2-meter nationwide data set available on Microsoft's Planetary computer that you can download through Stack for all the 3D data that's available. So you could possibly use that as a baseline, as the gentleman said before, on masking out the areas set below. And also, you can get the NAPE data, which is the summertime flight, which would catch your deciduous trees every 2 years. And that, I believe, is sub-meter at 60 centimeters right now.
Okay.
And if you could generalize out the 6-inch winter data that you get from the state to the same resolution as the NAPE data, then you can compare winter and summer.
Subtract the two and that would give me the...
Yeah, that'll give you your evergreens versus deciduous.
Okay, I like that. I'll see about incorporating that.
Which classifier did you use to classify the tree canopy?
Do you mean the random trees classifier? Is that what you're asking about?
Did you use a maximum likelihood classifier or?
It was the random trees is the name of the classification, actually. Yeah.
So you used machine
I tried them both ways, and from what I looked at for tree canopy classification on whatever everyone seemed to do, it was overall accepted that the random trees classification process was more consistent.
Do you use the bootstrapping or the boosting method with the random trees?
I think the bootstrapping, if I remember correctly.
Boosting tends to overestimate.
Okay.
Excellent.